Hello, welcome to the channel. My name is Ketan, and in this video we shall see what long division is. Long division is a process for dividing one polynomial by another polynomial. It's also used for dividing a large integer by another large integer, but in this video we shall focus more on polynomials. So before we actually do that, let's take a review of how we divide in the set of integers. So in the set of integers, generally when we divide a number by another number, we get a quotient and a remainder, and this division can be written as b equal to aq plus r, where b is the dividend, a is the divisor, q is something we call quotient, and r is the remainder. And r, the remainder, always lies between 0 and a. It's always strictly less than a, and it is less than or it's greater than or equal to 0. When it is equal to 0, we say that the division is a perfect division and a is the perfect divisor or the factor of b. Let's take a few examples. Let's divide this number 1912 by 7. Now this is a very simple example, and we are beginning with that. We know the table of 7, and therefore it's very easy to divide by 7. Here you can see we first divide by 7. 7 2s are 14, so we subtract 14 and we get 5 as the remainder. Then we take this one, take this one below, then it's 51, and 7 7s are 49, then 2 here, then we take this 2 below, then 7 3s are 21, and then we get 1 as the remainder. And note here that the remainder now here is less than the divisor, and therefore our division algorithm stops. We do not continue this division. We do not want decimals over here. We are not getting into that. We just want our division to be restricted within the set of integers, and therefore we stop here. And therefore we can write 1912 as 7 multiplied by 273, the divisor multiplied by the quotient plus the remainder. Okay, now let's go over to a little more complex example. Divide the same number 1912 by 73. Now here we do not know the table of 73, and therefore we have to do some sort of trickery over here. So now what we do typically is here is where we use long division, so to say, long division in the set of integers. Here we look at the digit that is in the leftmost position, so which is 7. Here it's the 10th position over here. We multiply by 7 to this number 1912. So we begin with the leftmost digit of the dividend, which is 1. Now 7 doesn't divide 1, and therefore we take the first two digits, 19. Again we do the same thing as we did in the previous example. 7 2s are 14, and now rather than writing just 14, when we write 2 over here, we multiply the whole divisor 73 by 2, and now that gives us 146, and then we subtract 146 from 191, and then that gives us 45. Now we shall take 2 down over here, and we shall repeat the process. We look at the first two digits, 45. Now 45, so 7 6 are 42, so therefore we shall place 6 over here, and rather than writing just 42 over here, we shall multiply 73 by 6, and we shall get 438, and after subtracting 438 from 452, we get 14, and 14 is the remainder, which is less than 73, and our algorithm stops over here, and we write 1912 equal to 73 multiplied by 26 plus 14. So this process of quotienting by the digits in the tens and the units place separately is called long division, and this can be extended to the set of polynomials, and that is the most important thing over here, that we shall be using the long division for polynomials. Let's see a few examples. So before we actually take examples, let us define the division in the set of polynomials. So quite in this, on the same lines as in the set of integers, we define the division in polynomials. So if suppose we want to divide bx by another polynomial ax, then after dividing we get quotient polynomial qx and the remainder polynomial rx, and here the remainder polynomial rx has the property that 0 less than or equal to degree of rx strictly less than degree of ax. Here the 0 less than or equal to is missing. Please excuse me for that. This actually should read 0 less than or equal to degree of rx strictly less than degree of ax. So degree of a polynomial is the highest power of x that is appearing in that polynomial. Fine. So as soon as we arrive at the polynomial rx which has degree smaller than the divisor degree, the degree of ax which is the divisor, we stop our algorithm, quite as in the case of the integers. So let's take a few examples. Let's divide x square plus x minus 2 by x minus 1. All right. So here while dividing by x minus 1, we again look at the leftmost monomial, which is x over here. We divide the leftmost monomial x square of the dividend by the leftmost monomial of the divisor, and after dividing x square by x we get x. Now we shall multiply this whole x minus 1 by x, and we shall get as a result x square minus x. Now we shall subtract this x square minus x from x square plus x, and we shall get x square will cancel with this x square, and we shall get 2x here. Then we shall bring down this negative 2 over here, and as a result we shall get over here 2x minus 2. And now again we shall repeat the process. Let us compare the leftmost monomial here 2x, compare it with x, divide by x, we shall get plus 2. Now again multiply by plus 2 to x minus 1, we get 2x minus 2, and after subtracting we get 0. So here the remainder is 0, and therefore the division is perfect. So that means x minus 1 is a factor of x square plus x minus 2. Let's take a few more examples. So little more complex example. So here we have a cubic polynomial as a dividend. Cubic means having degree equal to 3, and we have a linear polynomial as our divisor, 4x cube plus 3x square plus x minus 5 divided by 2x plus 1. So now again compare the leftmost, that is highest degree monomial 4x cube, and here with the highest degree monomial of the divisor 2x. Divide 4x cube by 2x, we get 2x square. Now multiply the whole divisor 2x plus 1 by 2x square, we get 4x cube plus 2x square. Subtract, we get x square. Bring down this x over here. Now divide this x square over here by 2x, we get half x. Multiply by plus half x to 2x plus 1, we get x square plus half of x. Again subtract, this x square cancels out, and what we get is half x. Bring down negative 5 over here, we get half of x minus 5, and again we divide this half of x by 2x, we get plus 1 over 4. Now multiply 2x plus 1 by 1 over 4 and we get half of x plus 1 over 4 as a result, and then subtract, we get negative 21 over 4. So now note here that negative 21 over 4 is a constant, and therefore it has degree, as a polynomial it has degree 0, and this polynomial 2x plus 1 has degree 1. So therefore we have arrived at a polynomial, the remainder polynomial, which has degree 0, which is strictly less than the degree of divisor, and therefore our algorithm here should stop. Okay, and we can write this as bx equal to ax multiplied by qx plus rx, as we wrote in the division algorithm statement. So this is the dividend equal to divisor multiplied by quotient plus the remainder. Okay, now let's take one more example. Let's divide this cubic polynomial by this quadratic polynomial. Now here the cubic polynomial is x cube plus 2x minus 3. Here the term of x square is missing. Some students may tend to make mistakes in this case. So therefore first we shall introduce a term of x square over here. So let's write this dividend as x cube plus 0x square plus 2x minus 5 and divided by x square plus x minus 2, and then we shall repeat the same process. First we shall divide the monomial x cube by x square, the leftmost, the highest degree monomial, that is x, then multiply x, the whole divisor x square plus x minus 2 by x, that is x, that will give us x cube plus x square minus 2x. Now subtract, so x cube term cancels and we get negative x square plus 4x minus 5. Now now we must divide the leftmost monomial, that is negative x square by x square, that gives us minus 1. So multiply the divisor x square plus 1 minus 2 by negative minus 1, and that gives us negative x square minus x plus 2, and after subtracting we get 5x minus 7. Now we cannot divide 5x minus 7 by x square plus x minus 2 because we cannot divide the leftmost monomial 5x by x square, and this has degree of this remainder 5x minus 1 is 1, and the degree of this divisor is 2. Therefore our algorithm stops over here. Now we can write this as x cube plus 2x minus 3 equal to x square plus x minus 2 multiplied by x minus 1 plus 5x minus 7. So that's all for this video. Thank you for watching. See you in the next video. Bye.